So, good morning class. Today we will discuss about chemical thermodynamics or chemical energetics. So, in this mainly we have to discuss about the flow of heat from between the system and surrounding, and then we will discuss about the first law of thermodynamics and second law of thermodynamics. So, this would be the entire topic which we are going to discuss in this chapter. So, let us begin from the very first to the basics, and then we will deal with the different laws of thermodynamics. So, first of all we are going to discuss about chemical thermodynamics, or it is also called chemical energetics, because it is mainly the branch which deals with the exchange of heat or exchange of heat energy between the system and the surrounding. So, basically when we are discussing about chemical thermodynamics or chemical energetics, so the basic two terms are very much common in the entire chapter, and the two terms are system and surrounding. So, first of all let us discuss the 2 points, two terms, that is system and the other one is surrounding. So, we have to discuss first of all two main terms, and the two terms are system and surrounding. So, what is system and what is surrounding? So, system is the part or it is the subject about which we are studying. So, whatever thing we are studying, whatever analysis we are doing, whatever the source, what is the interest point our, what is the source of interest. So, that part is called system, and except that system, what is the else part, what are the remaining parts, that is called surrounding. So, the point of interest, the studying material, it is called our system, and the rest of the world except that system is called our surrounding. So, let us take one example, a very simple example to understand the concept of system and surrounding. So, let us assume this is a beaker. This is a beaker and there is some water filled in this beaker. So, now if we are studying about this water, we are studying about its melting point, boiling point, freezing point, whatever with the matter, temperature, that means this water in this beaker is our point of interest. It is our subject of study. That means it will be our system, and except this system, what is the outer matter around this system, that may be air, that may be walls, that can be anything except this system will be assumed to be surrounding. So, like if we are studying about this water, any of the properties of this water, since we are studying about this water solvent, so this water will be a system for us because it is our subject of concern, it is our point of interest, and the entire world except this system is called our surrounding. So, these are the two terms which are frequently used in chemical thermodynamics. So, first is system and the other is surrounding. So, system is the part or subject about which we are studying, about which we are concerned, and surrounding is the rest of the world which is present except system or excluding system, and surrounding is called rest of the world or rest of the part except system. So, this was about system and surrounding. So, about which we are studying, it is called system, and leaving that system, excluding that part of system, whatever will be the exact things, what are the excluding parts of system, the remaining parts of the world, it is called surrounding. So, now on the basis of this classification of system and surrounding, there can be three types of systems. So, next we have to discuss about types of systems. Next we have to discuss about types of systems. how many types of systems can be there? So, basically there are 3 types of systems. First one is open system, second one is closed system, and the third one is isolated system. So, on the basis of system and surrounding, the exchange taking place between system and surrounding, systems can be classified into 3 categories: open system, closed system and isolated systems. So, let us discuss about each of them in detail, one by one we will discuss. So, let us first discuss about open system. Open system. Open system means a system in which both heat, that is energy we can say, and mass can be exchanged between the system and the surrounding, So, first of all we are discussing about open system. Open system is a kind of system in which both heat, that is energy, and mass can be exchanged with the system and the surrounding, that is heat can be absorbed or it can be gained as well as it can be loosed to the surrounding, and the same way mass can be gained or mass can be lost to the surrounding. Means the exchange of both energy and mass will take place between the system and the surrounding. There will be mutual exchange between the two, system and surrounding, and exchange of both will take place, and exchange of energy will also take place, and energy of mass will also take place between the system and the surrounding. Now, we are coming to our second type of system, that is closed system. So, a closed system is a type of system in which energy is exchanged between the system and surrounding, but no exchange of mass. There will be no exchange of mass. So, a closed system in which there is only the exchange of energy between the system and surrounding, but there is no exchange of mass between the system and the surrounding, and this type of system is called closed system. So, we discuss the first type of system is open system. In case of open system, there is exchange of both energy and mass between the system and the surrounding. There was exchange of both the things, that was energy and mass. But in case of closed system, we have exchange of only energy between the system and the surrounding, but there is no exchange of mass, and this type of system is called closed system. And then comes our third type of system, that is isolated system. And the isolated system is a type of system in which neither exchange of mass takes place nor there is any exchange of energy. So, it is a type of system where there is neither exchange of mass nor of energy between the system and surrounding, surrounding. So, there is no exchange of mass and no exchange of energy. So, these are the three types of systems. First system was open system, in which there was exchange of both mass and energy between the system and surrounding. Second was closed system, where there was only exchange of energy but no exchange of mass, that is matter. And the third type of system is isolated system, in which there is no change in mass, no exchange of mass, and neither there any exchange of energy. So, it is completely an isolated system, and so this isolated system is a complete adiabatic process that we are going to study in the next portions, in the next topics. But isolated system has no exchange of mass and no exchange of energy. Now we have to discuss about some of the properties of systems. So, now we have to discuss about properties of systems. So, we will discuss some of the properties of systems, and basically we have to discuss about two properties: intensive properties and extensive properties. We have to discuss about two properties: intensive properties and extensive properties. We will see what are these properties. But these properties are also called observable properties or they are also called macroscopic properties. They are also called macroscopic properties. So, because they deal with bulk matter in presence, so that is why they are also called observable properties or macroscopic properties. Macro means large in size. So, we have to basically discuss about two types of properties, that are intensive and extensive properties, and these properties are also called observable properties and macroscopic properties. So, let us discuss what are these properties. So, first we have to discuss about intensive properties. Intensive properties. So, the properties, what are intensive properties? The properties which do not depend on the amount of matter, present in the system. So, intensive properties are those properties which do not depend on how much amount of matter is present in that particular system, and these type of properties are called intensive properties. For example, let us see some of intensive properties. For example, like the first intensive property is concentration, volume, pressure, refractive index, surface tension, melting point, boiling point, viscosity, etc. So, these are some of the common intensive properties, and now let us see extensive properties. Now, let us see some of the extensive properties. So, the extensive properties are just opposite of these. They do not depend upon the amount of matter, they will depend on the amount of matter. So, these are the properties which depend upon the amount of matter present in the system. They will depend on the amount of matter present in the system. For example, number of moles, enthalpy, entropy, free energy, work function, etc. So, these are some of the examples of extensive properties. So, those are intensive and these are extensive properties. So, intensive properties are those properties which do not depend on the amount of matter present in the system. For example, concentration, volume, pressure, refractive index, surface tension, melting point, boiling point, viscosity, etc. But extensive properties are those properties which depend upon the amount of matter present in the system. For example, like number of moles, enthalpy, entropy, free energy, work function, etc. So, these are the examples of intensive properties and these are the examples of extensive properties. So, thank you class.